Let us get back now to the second objective of this lecture, which is to establish the connection between confidence intervals and hypothesis testing. I have already explained the basic idea, now I am just giving you the systematic procedure. As usual, identify the parameter of interest and specify the significance level alpha. Now, instead of going through this critical region or p value approach, directly construct the confidence region depending on the alternate hypothesis. If the alternate hypothesis is a two-sided one, that is of the not equal to types, then you construct a two-sided confidence region. If the alternate hypothesis is of the inequality type, either a lower tailed or an upper tailed, then you construct the one-sided region. Remember, we just derived the one-sided confidence intervals. For the left tailed one, we derive the upper bound for the parameter, and for the right tailed or the upper tail test, we derive the lower bound. And if the postulated value, let us say for the left tail test, is greater than the upper bound, then the null hypothesis is rejected. And for the upper tail test, if the postulated value is less than the lower bound, then the null hypothesis is rejected. That is all. So, let us understand this again through the same examples that we have seen earlier, and remember I had given confidence intervals and so on. So, here this is the example of testing the effectiveness of a training method. If you recall the data, we have gone through all those details earlier. What I want to draw your attention to is the confidence region that I have constructed now. This is, remember, what is alternate hypothesis? Mu is less than 75. So, which means it is a lower tailed or a left sided test. Therefore, I construct an upper bound for the mean. That means the maximum value that for the truth is 71 point something. If the null hypothesis is true, that is well, that is how you can think of it. But here we do not say if the null hypothesis is true and so on. We are saying for the data with the sample mean as the estimator, the maximum possible truth is 71 point something. But if the postulated truth is greater than the upper bound, then I reject the null hypothesis, and that is the case here. The postulated value is 75, and 75 is not the one of the possible truths. What are the possible truths? Anywhere from minus infinity to 71 point something. It is a very wide confidence interval, but at least it is not wide on both sides. That is very important. At least one bound should be finite. So, with 95% confidence I can say the truth is anywhere between minus infinity and 71 point something. However, the postulated value is 75, therefore, it is most likely that the null hypothesis is not correct. Therefore, we reject the null hypothesis, and that is the answer that we got even with the critical value analysis. The critical value approach says, look, if the null hypothesis is true, there we anchor things around the null hypothesis. That is the prime difference between conducting the hypothesis test the way we have learnt until now using the critical value approach and the confidence region approach. In the confidence region approach, we do not really stick to the null hypothesis at all. We just use the data and estimator and construct a confidence region, and now bring the null hypothesis into picture and ask what is the postulated value. If the postulated value falls into the confidence region, then we fail to reject the null hypothesis. Very simple. So, here there is a subtle but very important difference between in the way we conduct our hypothesis test. In a critical value approach, we say if the null hypothesis is true, then the extreme value that I am willing to tolerate is minus 1.833. Now, the observed statistic is left lower than or more extreme than what I am willing to tolerate, therefore rejected the null hypothesis. But now suppose I want to ask what if the suppose I want to repostulate the truth and say is mu naught equals 71. Suppose the null hypothesis now changed to mu naught equals 71. Will I reject the null hypothesis? Well, again I have to compute the observed statistic and then compare. Definitely then the null hypothesis would not be rejected. But region approach, I do not have to compute the statistic at all. I can say that 71 is one of the possible truths, therefore, the null hypothesis cannot be rejected, all right. So, that is the difference that you should observe between using the confidence region approach and the standard approach for hypothesis testing, and this is the advantage that holds for all kinds of hypothesis tests for other parameters too. Now, until now we have talked about means. Naturally, we move on to confidence intervals for differences in means. Once again, you can go through the procedure and starting with the sampling distribution for the sample means, as the case may be unequal variances, equal variances, paired difference and so on. Pick the sampling distribution, appropriate one, write the probability region, and then write the 100 times 1 minus alpha % confidence region. So, I have essentially done that and reported the confidence regions for you. All these symbols are some things that we have seen before in the sampling distributions and also in hypothesis testing. We will quickly move on to the example for the case of unequal variances, where we were comparing yield data. Remember, I had reported the confidence intervals for you. For the yield data, the null hypothesis was that both reactors give you the same yield, and the alternate hypothesis is no, there is a difference. We do not know which one gives me more yield, but I do not care, I am interested in either. So, then it becomes a problem of constructing two-sided confidence region. As you can see, I have given the two-sided confidence region. How did I arrive at this? Use this equation that I have on the top for the unequal variances case, equation 5, and then construct the confidence region, plug in all the values, and you will find, in fact, I showed you also last time in R the confidence region, if you recall, when we construct the T dot test for the yield data. In fact, if I were to conduct the hypothesis test a standard way, I have to specify the postulated truth, but if I am only constructing confidence region, all I have to do is specify the alternate hypothesis, and here the default alternative is that is a two-sided one, and the variance dot equal is false, that means unequal variances case. I do not have to worry about the postulated difference at all. So, let us do that, and you see the confidence interval coming out of the T dot test here, which is what I have reported for you in the slides. In fact, you can see even if I change the postulated value, the confidence interval remains the same. All right, what would change is of course the p value. You can even in fact the p value. So, you see if I change the null hypothesis, then the confidence interval remains the same, and the observed statistic is going to change, obviously, because observed statistic depends on the postulated value. What I am trying to show you here is the confidence interval construction is independent of the null hypothesis, which is what I have explained in detail earlier. That is the advantage of using the confidence interval approach. All right. So, let us go back to the problem. The postulated difference is 0, whereas the confidence region for the difference is given there, and 0 is not contained in the confidence region. This is a 95% confidence region, and therefore, we reject the null hypothesis. Now, we can ask the question, what if I want to conduct a hypothesis test where I want to ask that the difference between the yields of A and B reactors is 2, and let us say the alternate hypothesis is that yield A gives me 2% more than the yield of B. So, what is the difference now? Do I have to recalculate the confidence region? No, I do not have to. Now, the postulated difference is 2. So, again I go back to the same confidence region and ask if 2 is contained in the confidence region. It is not. Therefore, I once again reject the null hypothesis that the difference between the yield of A and B is 2 in favor that it is not equal to 2. But suppose the alternate hypothesis is greater than 2 that I have asked here, then what kind of confidence region should I construct? Then I have to construct a one-sided confidence region, where I construct the lower bound. So, here earlier I just answered the question when the alternate hypothesis is yield A minus yield B is not equal to 2, but suppose I want to answer yield A minus yield B is greater than 2, then we will have to construct a one sided confidence region, and I leave that as a small exercise to you and see if this postulated difference now is contained in the one sided confidence region. So, to summarize, the confidence region depends on the alternative hypothesis, that is a type of alternative hypothesis, whether it is whether it is inequality type or the not equal type. That means whether it is a one sided one or a two sided one, but it does not depend on the postulated value. Once you consider the confidence region, you can test with all possible postulates so long as the alternate hypothesis is of the same type, that is all. Very good. So, let us quickly move on to the pair testing, where we looked at the weights in a weight loss program before and after, and here to construct the confidence region we use this expression in equation 7, provided we are looking at a two sided one, and this is that of a two sided one. We wanted to see if there is a difference between the weights in a weight loss program, and the confidence region is reported here using the formula that I have given in equation 7, and the postulated difference is 0. That means there is no difference between the weight before and after, but the confidence interval does not contain that, and therefore we fail to reject the we reject the null hypothesis and conclude that 0 is not a possible truth. Now you can test, now you can ask what can I say that the difference is maybe let us say 8, and the alternate hypothesis difference is not equal to 8. In that case the null hypothesis would not be rejected, because 8 is a possible value. But if you were to ask the difference between let us say even the difference between the weight before and after is 10 kgs, very nice, still the null hypothesis would not be rejected. But suppose the alternate hypothesis of the type the difference is greater than 10, then I will have to construct a one sided confidence region and then answer that question of the alternate hypothesis, which is the weight difference is greater than 10. So, I leave that as an exercise to you, and also what you should do is construct a confidence region assuming, like we did in the hypothesis test case. I had asked you to do this as well there, treating the the samples before and after as independent. That means we apply a 2 sample t-test. There we reevaluate, that is we reevaluate the critical value, recalculate the critical one, and we use a different kind of statistic. Here as well, suppose you were to treat this inadvertently as a case of the populations being independent of each other before and after, then the confidence region construction would be different. In what way? Instead of using equation 7, you would probably use equation 6 or equation 5, depending on whether you assume equal variability or unequal variability. Clearly the confidence intervals would be different, and what I want you to do is go ahead and calculate those confidence regions. Either you can use the formula here, or I have the data set there uploaded for you on the website, from where you can run the t dot test and obtain the confidence intervals, setting variance dot equals false and paired also to false, and see if you reject the null hypothesis or fail to reject the null hypothesis. Very good. Now let us move on and talk about the confidence intervals for other parameters. This is going to be a swift thing, we are going to just swiftly breeze through this, because as I said, the derivation of this confidence regions is now kind of standard. Look up the sampling distribution of the estimator, write the probabilistic region, write the confidence region, and you would obtain the confidence intervals that I have given you in equation 8, 9 and 10 and so on. So, once again here we have a two sided confidence region and a one sided confidence region for the variances, and we can also give a two sided confidence regions for the ratio of bounds, ratio of variances. So, let us recall an example quickly where we are comparing variability of yields, right, and we have gone through this example in the previous lecture, and we had rejected the null hypothesis based on the critical value approach. Now, if I use a confidence interval approach, the confidence region for the ratio of variances is 0.152 and 0.473. Why did we construct this kind of a confidence region? Because the alternate hypothesis is of the not equal to type. So, it is a two-sided confidence region and it does not include the postulated value which is 1, that means the variances are equal, therefore, we reject the null hypothesis. So, excellent. So, we are actually now hopefully becoming experts in the confidence interval based hypothesis testing. And finally, the confidence interval for proportion, again to read this out would be like reading a small sermon, we will not do that. Again you can actually read, derive these expressions, confidence regions two-sided and one-sided, starting from the sampling distributions. Remember that all the assumptions that we made in deriving the sampling distributions hold here as well. That means if any of those assumptions are violated, these confidence intervals are not valid anymore, you will have to rederive them. And let us look at this example for the defective controllers, where we looked at this motivating example when the manufacturer claims a maximum of 5% defective controllers and so on. And there we had failed to reject the null hypothesis based on the critical value approach. And here the test is actually not a two-sided one, because the alternative hypothesis is of the inequality type, P greater than P naught and P naught is 0.05. Therefore, I need to construct a one-sided confidence region which involves constructing the lower bound on the proportion, and the lower bound turns out to be 0.0037. I have just calculated that in R by using this expression in equation 12, all right. And it turns out that the postulated value is within the confidence region, postulated value is 0.05. That means it is greater than the lower bound, so fine, I failed to reject the null hypothesis. In fact, the manufacturer could have even claimed 0.01 and still the null hypothesis would not have been rejected, correct. So, that is the thing here with the confidence regions, using the confidence regions for hypothesis testing. And with this we come to a close. Of course, I could have discussed the differences in proportions, but again it would be a routine thing. What I would advise is go to the read the book up, read up the book on by Montgomery and Runge or the other book, look up the confidence region for the differences in proportions, work out the example that we did in hypothesis testing and see if you arrive at the same conclusion that we made with the critical value approach or the p value approach. Now, there is one point that I want to make. It was easy to derive the confidence regions because we knew the sampling distributions, that is the step 2 is critical. If I do not know the sampling distribution, then there is no way I can derive a confidence region because I cannot write the probabilistic region. Here it was easier to derive the confidence regions because the analytical expressions for the sampling distributions are available. Now, in practice, in reality, there may be many situations in which we do not have the sampling distribution expression at all. In linear regression we have, but in nonlinear regression maybe for large sample sizes you have, but in very complicated estimation exercises which are not uncommon today, it is quite difficult to derive the sampling distribution analytically. Then how does one construct confidence region? Does one construct at all? Well, yes, and that is through the use of Monte Carlo simulations, or you can say bootstrapping methods or surrogate data analysis and so on, which typically forms a topic in an advanced course on estimation or advanced course on statistical inferencing today. We are not going to talk of bootstrapping in this course, but I thought you should know this, especially for those of you who are conducting research in some kind of an advanced data analysis or advanced statistical inferencing. Okay then. So, hopefully you enjoyed this lecture. In the next lecture, we are going to look at hypothesis test in the linear regression scenario, where we will set up the hypothesis null and alternate hypothesis for the slope and intercept, and also for correlation to begin with, and then at the same time we will also talk of confidence intervals, and then ask in a linear regression what are the typical hypothesis tests, not all of them, but a few of them that we conduct, followed by the closing lecture where we will talk of sensitivity of hypothesis tests to one of the main factors, which is sample size. Okay then. So, see you in the next lecture.